Thank you very much. Before I start, I want to answer the question that you're probably all asking, which is, why is there a kangaroo on the slide? I thought this was a tech conference. It turns out that kangaroos are the world's most efficient land animal. So kangaroos are really good at taking elastic energy and converting it to kinetic energy with very little loss. I know this partly because I have a PhD in physics, but mostly because I've spent much too much time thinking about efficiency. I worked for Red Hat, but pretty much through my whole career, as I mentioned, I've really been, trying to make things efficient. So I started out working as a JVM performance engineer, trying to make garbage collection efficient. And then I switched tack completely, and I switched to being a consultant. And so I was really trying to help businesses adopt lean to make themselves more efficient. And then I decided that was quite hard, and people were hard, machines are easy. So I've switched back, and now I work on Quarkus. And Quarkus is in this really nice position because Quarkus makes really efficient use of the machine, but it also helps people be more efficient. And that's quite a nice trick, because usually you have to trade off people efficiency versus machine efficiency, although that's a different talk. So given that context of trying to make everything more efficient for my whole career, the title of this talk seems a bit ridiculous. Is efficiency a good thing? Of course it's a good thing. We can all go home. Yay. Well, sort of. I mean, it seems so obvious that efficiency is good. None of us in our personal life aspire to be inefficient. No organization has ever put an OKR that said, yes, this year we'd like to be 10% less efficient than we were last year. It doesn't make any sense at all. But it is a little bit complicated. Like everything, it depends. So if you're writing a talk about efficiency, of course, the first thing that you do is you go to Google to get the definition of efficiency. But I was surprised because when I did that, what Google did was it suggested a different question, which is, who invented efficiency? Because even though this striving for efficiency seems like such a fundamental human urge, efficiency is actually a relatively recent concept, and it's only something that we've been talking about for the last 200 or 300 years. We really started talking about efficiency, we really invented efficiency at the dawn of the Industrial Revolution, when people started looking at steam engines and thinking, a steam engine, it takes energy in and it puts energy out, but only a small portion of the energy it puts out is useful. How can we make that proportion higher? And then we took those same ideas and we applied them to organizations and to people at the end of the 1900s. So with a process, you have time and money that goes in, and then hopefully, if you're lucky, you have value that comes out, hopefully. And so then we started again, taking those ideas and we applied them to manufacturing. So if I have value that goes into a factory, things like raw materials, can I get something that's more valuable coming out of the factory? And, again, we continued this and we applied it to all sorts of areas. So in the 1960s, we really started looking at the efficiency of software, the efficiency of computers. You put time and electricity and hardware and programmer tears into software. Can you get something that is hopefully an answer out the other side? So really, when we think about efficiency, I think that the first takeaway is we have to consider all kinds of efficiency. We have to consider the efficiency of our processes, of of production, of software, of people. And this is probably something that a lot of us will think, yeah, that makes total sense, because we've been working on this efficiency as a species for 200 years. We're getting really good at it. So if you look at the efficiency of steam engines, for example, between when they were invented and the 1940s, which is when they stopped being used, the efficiency went up hugely. That's a logarithmic scale, so that jump in efficiency is big. If you look at the efficiency of computers, probably most of you are familiar with Moore's law. How many of you know Cummins' law? No hands. So Cummins' law is kind of like Moore's law, but I think it's cooler and happier. Cummins' law says that the energy efficiency of computers doubles roughly every 18 months. So that, again, that's a really good thing. We are getting so efficient. And in my professional life as well, I can see this efficiency. So I work on Quarkus, as I mentioned, and Quarkus is incredibly efficient in terms of throughput and footprint and startup time and everything. And this is a really big change from how it used to be. So I've been a developer for longer than I care to say. And in 2010, the Java ecosystem was assuming that every time you did anything with your JVM, you would go make a cup of tea because it took so long to compile and then it took so long to start the application server. And, this just isn't the case anymore. Now, if you've got something running on GraalVM, I benchmarked it, it actually starts faster than an LED light bulb. It is instantaneous as far as we can perceive. It's really cool. And, again, with Quarkus takes advantage of that technology to give you that speed. This is awesome. This is really good news. We've automated all of the things as well. We're getting so good at automation. So it used to be we had all of these manual processes, but now we've got GitOps, we've got infrastructure as code. And as well, we've gone further. We've got us as code. So I drew the illustrations in this talk, but I didn't actually need to have done that. I could have just gone to DALL-E and had it draw kangaroos instead, and it probably would have done a better job than I did. And if you're writing a talk in 2024, the first thing that you do is Google the definition of the thing that you're supposed to be talking about. And the second thing that you do is you go to ChatGPT and you say, could you please write my talk for me? I made a rookie mistake. I wrote the talk and then I went to ChatGPT, which was one of the most depressing experiences of my life because I'd worked really hard and it produced all of these beautiful paragraphs, including, I thought I had this really nuanced, interesting talk with, some unexpected original observations. They were all there in ChatGPT. So, the computer was basically laughing at me and saying, silly human, there is no original thought anymore. So that was slightly depressing. But what's more depressing, if you weren't depressed enough already, is the fact that even though we've been working on this efficiency thing for 200 years, we're really not very good at it. So one of my favorite stories is, this is about 10 years ago in the early days of the cloud, well, sort of pre-cloud. And we had some provisioning software, and we told the client, this could provision your instance in 10 minutes, which now sounds kind of pathetic. At the time, this was amazing. The client was like, oh, yeah, and I want that. And then they came back to us, and they said, oh, this software you sold us, it doesn't work. It takes 3 months from when we click the button to when we get the instance. And we thought, that's weird. I'm fairly sure I read the code. That's not how it works. So we investigated, and it turned out what had happened was that they had put an 84-step pre-approval process inside that automated provisioning. So of course it took 3 months. In fact, it's amazing it didn't take longer than 3 months. But of course, that's because of people, right? People make things inefficient. But the fact is, even our software is often really pretty inefficient. I heard a story of LinkedIn, and they went and they had a new feature in their mobile app, which they were really excited about. And so they went and did some user research. And one of the places that they went to do user research in was a sort of a medium-sized city in India. And so they sat down, with the user and showed them their feature. And they had a blank screen. And they waited, and it was a blank screen. And they're like, yeah, I don't think it was supposed to work like that. And what had happened was they had assumed bandwidth and processing capacity that just wasn't there for these devices. And so effectively, they had written completely useless software at great expense. So this is bad. We have created a web that is useless for part of the audience it's supposed to be serving. Fail. And, we see this waste everywhere. So one of the big problems that our industry has is the problem of zombie servers. Around a quarter of the servers out there are doing no useful work. Even if your server is doing work, it's probably running at about 12 to 18% of capacity. And so this is a shocking waste of money, because computers cost money, but it's not just money that's being wasted. There's all of the electricity to run those servers. There's all of the water to cool the data centers and for the manufacturing of the computers. There's all of the e-waste when we finally throw out those servers instead of repurposing them. And of course, when we think about sustainability, there's all of the embodied carbon in those servers. So again, this is kind of terrible. Why does it happen? Is it just because we kind of forgot to be efficient? I wish that was the case, but it's actually worse than that. We actually cling on to inefficiency. We like inefficiency. And this again has to do with incentives. So sometimes when I talk to conference buddies who work for vendors, and they maybe have a cool product, and it will make teams more efficient. And so they'll be talking to someone and they'll say, yeah, let me tell you about, how this makes your team more efficient. And they'll be talking to the manager and the manager will say, make my team more efficient. Oh no, I definitely don't want that. Meanwhile, the salesperson sort of going on and, explaining the benefits. And then they have to step back and say, well, wait a minute. How could you possibly not want my amazing product that makes you more efficient? And it's because of how we measure the status of people. You have more status if you manage a large team of people doing busy work than if you manage a small number of people and a large number of machines. That's our incentive structure. And so as long as we have that incentive structure, we don't have the incentive to get rid of waste. And of course, that's managers. We're all individual contributors here. We would never be so silly as to... But, even us, we often have similar things where we see something that could be better, but we know our mate is maybe the one who might be on the chopping block if we get rid of this process and replace it with a shell script. So we don't say anything. So that's the next takeaway, really, is inefficiency is everywhere. We need to work to drive it out. So and I think, you're all staff engineers, that level. That's how you got to where you are, is by doing this naturally. Drive out those stupid processes, fix the bloated software, sort out the resource utilization, and then also look at the incentives to make sure you don't have incentives that reward inefficiency. But once you've done all that, then you should go further. Because I love this quote from Peter Drucker. There is nothing so useless as doing efficiently that which should not be done at all. So often we make something efficient, we do the micro-optimization, and we say, job done. But really, we should be going deeper. We should be thinking a bit broader about this. Many years ago, I worked in a team, and we had a weekly defect triage meeting. And so the defect would come in, and we would try and decide what the priority was. And we would talk, maybe for 5 minutes each meeting, I was like, da-da-da. And then we would click the button to assign that defect to be priority medium. Every single time. And eventually someone said, I've got an idea. Let's invest in writing some automation to replace this meeting with a shell script that goes in and sets the priority to medium. That would have been a reasonable thing to do. But actually, the correct thing to do was just to get rid of the field. If this field had so little value that a machine could set it, why is it even there? Just get rid of it and save a little bit of screen real estate. And I often think the same thing when we talk about AI. We say, AI, it's so good. It can fill in all of this totally pointless boilerplate, much more efficient than I could. I've got another idea, right? Let's just get rid of the boilerplate. And this is something, again, that with Quarkus often the programming model is trying to do that. So as a little example, If you are a Java person and you are doing logging, you always have to copy-paste the name of your class into your logger initialization. It is annoying. With Quark, as we've just said, we could just get rid of that and do a bit of bytecode manipulation at build time so you don't need that stupid step. It's cool. So when you're thinking about getting rid of inefficiencies, don't just go for the obvious ones. Think differently. Go for the kind of the radical waste reduction rather than just the easy things. Okay, so that's good. We've sorted out all the inefficiency. We can all go home, right? Well, not quite. Because is efficiency a good thing? It depends. Often what we see with the drive to efficiency is it's not necessarily actually saving us as much time as we think. And one of the things that I've really noticed with AI in particular, but also with other efficiencies, is sometimes it's not actually getting rid of work. It's just shifting the work to a different place. So probably half of the internet laughed, of course, when the news came that the Amazon's Just Walk Out service that had been billed as an AI service was actually powered by people in India watching you shop. It wasn't AI, it was actually Indians, not AI. And you know, that one is sort of easy to laugh at, but we see this shifting of labor everywhere. So for some of the other services, it's maybe not as obvious, but something like ChatGPT is really built on a lot of rather low-paid, rather horribly, you know, sort of traumatizing labor from Africa. That's, again, that's, you know, maybe something that we want to think about. And of course, sometimes the person that they're shifting the work to isn't someone in Africa working for £2 an hour. Sometimes the person that they're shifting the work to is you. And the worst is that you go, oh, this is amazing. I just saved myself so much time as you do more work. So if when we're using some of these tools, for example, sometimes it actually takes longer to write the natural language prompt that covers all of the edge cases than it would have done to just write the code, because code's fairly optimized. And then once we get the answer back, we have to spend quite a long time reading it and validating it. And then once we've done all that, we have to maintain the thing because the code was maybe somewhat questionable quality. So, you know, all of these tasks have been shifted to us, which maybe wasn't what we signed up for. And, you know, it's kind of easy to laugh because sometimes the quality of what comes out of these systems is not that good. So I love this one that if you ask, they fixed it now, but if you asked what the world record was for crossing the English Channel entirely on foot, so some of the earlier speakers, you know, instead of taking the train, they could have done this instead, but they would have needed 14 hours instead of the 10 hours because it takes 14 hours to cross the channel on foot, maybe. You know, so this is bullshit as a service. And you know, again, it's easy to laugh, but this is actually what the incentive was. This is what the function of the system. So we have to understand that when we decide how to use that. And for something like the channel crossing, it's easy to laugh because it's obviously wrong. With the code, often the incorrectness is a lot more subtle, but it is still there. And so the effect of taking all of this incorrectness and putting it into our code base is that we are pushing the quality of our code bases down. And let's be honest, the quality of our code bases wasn't that high to begin with. And the quality problem is, I think, much more obvious when you're using ChatGPT for something that you already know how to do. And the use case for ChatGPT is, in general, something that you don't know how to do. So I noticed this recently because I wanted to do, you know, to show generating some Quarkus code. So I put in the prompt, and it gave me back some code, and I thought, oh yeah, that looks really good, and that saved me a lot of typing, cool. But then it kept going, and then it kept going, and then it kept going, and then it had all of this code. And this code, it wasn't harmful, well, it wasn't incorrect, but it was completely unnecessary code. The beauty of the programming model was that you didn't need the code. ChatGPT didn't know that, and so again, the training tends to reward verbosity, so we just splatted out this code. And so it seemed like it was efficient. Look how much typing it did in such a short amount of time. But it was an illusion of efficiency because it shouldn't even have been doing the typing. It's back to the Peter Drucker quote that don't, if you do it and you shouldn't have done it, it's really not efficient. Okay, so that's bad. How do we fix it? Of course, we want to be data-driven. We want to measure. We want to measure the efficiency of people, and that will allow us to solve the illusion of efficiency, of course. Well, I think I can just probably skip the next 10 slides, because you know what's coming, right? You get what you measure. Think very carefully about, are you measuring what you actually want? Because otherwise, you get this. So if you have a bingo card with complaining about the McKinsey productivity research, then you can cross that off. It is so easy. It is so tempting to measure wrong. So we have to be really, really careful about this. And I think this partly comes back to that history of efficiency. The notion of efficiency was originally something that we applied to machines. We then extended it to people. We extended it to business and manufacturing, and then we kind of went back to machines. But what we're doing here is we're taking something that was designed for machines and we're applying it to people, and we're assuming that the concepts translate exactly. And this is Taylorism. This is treating machines as though they were equivalent to people, or, to put it the other way around, we're treating people as equivalent to machines. That's not good for a whole bunch of reasons, because if you continue that reasoning, then you get things like this. So Amazon drivers having to pee in bottles because they've been optimized to a point where their natural bodily functions aren't included in the timetable, which is terrible, obviously. So when we strive for efficiency, reducing waste is good, reducing humanity is bad. And for us in the tech industry, obviously, I think most of us do get toilet breaks at work. Actually, having said that, if you have back-to-back meetings, they tend to eliminate toilet breaks. But leaving that aside, we are in a privileged position. We are in a comfortable position. But even us really are not immune to this push for efficiency. What we're seeing now often is that efficiency is being treated as a synonym for layoffs. And so when you're in a company that's doing layoffs, you get this sort of culture of fear. Is my job safe? I won't speak up because I don't know if my job is safe. And so then that tends to drive away a lot of the behaviors that got us to this point in our career. It has a corrosive effect. And I mean, there's all sorts of things that we can do really wrong in tech if we try and measure the efficiency of people. Because when you're measuring in general, measuring is hard, you have to find a proxy, and then that's where the problems start to come. Sometimes it's tempting to use sleep as a proxy for efficiency or use sleep as a proxy for productivity. So I saw this recently. I heard of a founder who monitors, so this was a VC, who monitors his co-founders and employees' productivity via a Whoop group. I've never heard of Whoop, but I'd never want to use it. The team is collectively averaging 5.5 hours of sleep per night. And so I thought the next bit that went on was, this is really terrible. Our employees are going to be making mistakes. It's like they're going to work drunk, because that's the effect of sleep deprivation. How do we stop this? And instead it went, if you haven't implemented this already at your portfolio to companies to monitor founder work ethic, I strongly recommend it. Don't do this. Because it's not just ethically wrong. It's also factually wrong. It is counterproductive. And we know this for people, but even for machines, it is true. So going back to those steam engines, the benefits of an education in physics is that you know that even for something like a steam engine, there is a physical fundamental limit to how efficient it can be. It's around 40%. Most steam engines operate at much lower than this limit, partly because it's really hard to get them to the limit, but also because if you operate at the limit, they break down. So true of machines, true of people. And even, that idea that the machines break down is something that we really need to think about, because when you're looking at efficiency maybe you want, but you also need to think about your other requirements, such as resiliency. What other NFRs do you have? Because some of you may have seen this analogy before. A dog, in many ways, is not particularly efficient in its design. This is sort of, it seems to have more legs than needed. Because we could optimize this dog, and we could make something like a stool. This is much more optimum in the number of legs that it has. But there is a problem. If you take the dog, and for whatever reason, don't try this at home, you remove one of the legs of the dog, it is still a perfectly functional dog. It will run around the park. It will sniff other dogs. It will do doggy things. If you take your stool and you remove one of the legs, it is not going to run around the park sniffing other stools. It is going to be a non-stool. So we sort of optimized it to the point where we really lost a lot of resiliency. And we probably didn't want to do that, because resiliency is also a very good thing. And resiliency in our systems is good. Resiliency in our people is also very good. So we need to have some accommodation for play, because otherwise bad things happen. And this isn't just me saying this. There is an impressive volume of research that makes this same point, that having fun in the workplace, it's good for business. It improves business results. And what all of these studies tend to find is that if employees are having fun, then they work harder, they're more productive, and they take less sick leave. So this is clearly a good thing. And we can quantify this pretty precisely. So the Harvard Business Review found that your brain at positive is 31% more productive than your brain at negative, neutral, or stressed. And so again, if you go to your management and you say, I can make us 31% more productive, they're like, yeah, awesome. What do? We make people happy. Oh, no, I'm not sure about that. So how do we get into a positive mindset? It's not as easy as just watching cat videos, right? It has to be something more fundamental than that. It turns out it is literally as easy as watching cat videos. There was another piece of research, and they found that individuals who had just watched a comedy video, for full disclosure, they didn't specify it was about cats, but we can assume, were 12% more productive. So again, if you go to your management chain and you say, I can make us 12% more productive, they're like, okay, well, that's not as good as the 31%, but I'll take it. How do we do it? Cat videos. Oh. So I think, we can kind of intuitively grasp this idea that, play, we work in a creative industry, we do problem solving. Children, when they're trying to solve problems, play. Adults, when they're trying to solve problems, should play. But there's another result, which is perhaps even more surprising, which is that doing nothing at all, not playing, just doing nothing, can really help productivity. And the physical mechanism for this is something that's called the default mode network. So the default mode network is, in general, if you're doing something, some area of your brain will have higher blood flow to show the activity. If you're doing nothing, an area of your brain called the default mode network gets more active. And so this area of the brain is associated with problem solving. It's associated with imagination. It's associated with mental time travel, which is a phrase I really like, but basically that just means thinking about what happened to you today and what's going to happen to you tomorrow. So the time spent, this is why we all solve problems in the shower, is because your default mode network is really active when you're in the shower. If you don't want to waste the water, things like knitting, also very useful. So this is kind of a psychology thing. And again, I think perhaps, if you go to your management chain and you say, I've learned all about psychology, and psychology says that we should have more spare time, management will say, no. But actually, this is something that, again, is really backed up by hard mathematics. Queuing theory tells us, unambiguously, that systems have to run under capacity. Systems have to have idle time in order to function. So the basics of queuing theory is nobody thought that they'd get a queuing theory lesson at the very last moment on the talk when they wanted to go home. So queuing theory says that you have an arrival process, which we assume follows a Poisson distribution. Those arrivals go into a queue, and then there's servers, and then once things get served, then it's completed work. So this applies to people, this applies to machines, it applies to everything. It's awesome. Because obviously, if you have insufficient server capacity, you get these high wait times. On the other hand, if you don't have any work coming in, then you end up with idle servers. Both of those are bad. So then what queuing theory allows us to model is, how do I trade off these two bad things against each other? And the really interesting thing that queuing theory tells us is you cannot have 100% utilization in your servers, because you can see this curve is exponential. So if you have 80% utilization and you go to 90% utilization, and you put that, again on your end of year assessment to say, I went from 80% utilization to 90% utilization, I'm a hero, except that all of the latency in your system is now doubled, which makes you really not a hero. So what you need to do is you need to balance off that delay cost of either having work that takes a long time to get done or work that you have to throw out against the cost of the idle capacity, which of course you also want to avoid. And we can see this, again, in lots of different places. So when trains are running, they do not run at the highest possible speed, because if they ran at the highest possible speed, they would have no slack in the system to run faster when something happened. So in order to keep to the timetable, to have that predictability, we have to sacrifice some efficiency. So I mentioned some depressing things, but I think this is really, really good news, because what this is telling us is that relaxing has business value. Play has business value. Doing nothing has business value. Mathematics confirms it. So, second last takeaway of the day is, when you're measuring, please measure thoughtfully, because you will get what you measure. And efficiency, paradoxically, is not always efficient, and that embracing the fun improves your efficiency. So you really need to make sure that you're optimizing the thing that you care about, not the thing that's easy to measure. Because efficiency can look really unexpected. It can look like taking a shower. It can look like lying face down thinking. It can look like playing ping pong. And let's go back to, this idea of the kangaroo. If you go to your boss and you say, I am the team kangaroo because I'm so efficient, they'll be like, yeah, I like that. But the kangaroo is the most efficient land animal. It's not actually the most efficient animal. The most efficient animal in the world is the jellyfish. It is super, super efficient in terms of its energy utilization. But if you go to your boss and you say, I am the team jellyfish because I'm so efficient, they're not going to be convinced. So we do need to frame the problem correctly before we can get the right answer. So to wrap up, do look for waste. Waste is really annoying. Get rid of waste, but measure really carefully and beware that illusion of efficiency. And remember that people and systems, and including you and me, function better with some idle time. So with that, thank you very much. Enjoy, well, not the rest of the conference, because it's the end of the conference, but I hope it's been useful. I think the slides will be distributed, but they are also there if you're impatient as well. Thank you.